This video will cover the Descartes rule of sign to find the possible positive and negative roots of a polynomial. So Descartes rule of signs says the number of positive real roots of a polynomial is either equal to the number of sign changes between consecutive coefficients of p of x or is less than that by an even number. The number of negative real roots of a polynomial is either equal to the number of sign changes between consecutive coefficients or is less than that by an even number. So, in real world terms, it means if for every sign change with the original polynomial, there's going to be one positive real root, or at least. For it to be negative, you have to substitute negative x into the original polynomial, but we're going to get to that. So let's just use Descartes' rule of signs to see how many real roots there can be. Remember, we're talking real, not imaginary. So here's what it says. You have the polynomial x to the third minus x squared plus 1. I want to know how many possible real roots we can have. So using Descartes' rule of sign, I have to know how many sign changes there are between consecutive coefficients. So I have a positive coefficient, a negative coefficient, and a positive coefficient. So how many sign changes do I have? A sign change is either from positive to negative or negative to positive. How many do I have? So let's see. I have a positive to a negative, so that's 1. I have a negative to a positive, so that's 2. So I have 2 or 0 positive real roots. Again, the reason why it's 2 or 0, by definition of Descartes' rule of sign, less than that by an even number. So since I had 2 sign changes, I can have 2 or an even number less than 2, which would be 0. So again, that's only for the positive real roots. Now we have to check out the negative. So possible negative roots, you have to substitute negative x in for x. So instead of positive x, it's going to be negative x to the third minus negative x squared plus 1 equals 0. From Algebra 1, you should know your rules, that a negative raised to an odd power stays negative, so that's negative x to the third. A negative raised to an even stays positive, so that's going to be minus x squared plus 1 equals 0. And we're going to apply Descartes' rule of sign. So we have a negative, negative, positive. No sign change? Yes, we do. We have 1. So we're going to have 1 real negative root. There's the example. We'll do another one. Again, Descartes' rule is just an estimation of how many real solutions. Again, you can use your calculator, and we're going to do that right now. So let's enter x to the third minus x squared plus 1 into our calculator. I have it in my calculator here, and let's graph. So I said I have one real negative root, and we can see right here that we have one negative real root, and I said we either have 2 or 0 real positive roots. Since we don't cross anywhere on the positive x-axis, we can confirm that there are 0 real roots. So again, using the calculator, we know it's 2 or 0, but it's no longer 2. We know it's 0 because we checked with the calculator, with the graph, actually, on calc. So let's try another one. Descartes, how many possible roots can we have? So first one's pretty easy because you just take them all. You don't plug in negative x. So we have a positive, negative, positive, negative. We have 1. We have 2. We have 3. So we have 1 sign change, 2 sign change, 3 sign change. So we're going to have 3 or 1 real positive root. Again, that's positive. And next, we got to substitute again for the negative and for x. So it's going to be 2 negative x to the 4th minus negative x to the 3rd plus 3 negative x squared minus 1. So negative raised to an even, positive stays negative, but a negative turns to a positive. It stays positive. And we want to see how many sign changes. So we have a plus here, plus, plus, negative. No sign change, no sign change, 1. So we have 1 real negative root. Again, Descartes' rule of sign, seeing how many times you just go from positive to negative or negative to positive. So in the original, we changed signs 3 times. So that's always for the real positive side. You substitute in negative x to check the negative side, and we only had 1 sign change. So we have 1 real negative root. Now let's check out the graph to see if we have 3 or 1 real roots on the positive side. So go to your calculator, go to y equals. We're going to turn off the previous example and enter the second one. So we have a new graph. And then here we can see that we have 1 negative and 1 positive. We don't cross the x-axis 3 times. There you go. One more look. If you have any questions, ask during class, before school, or after school. Aloha.